Ladies and gentlemen, esteemed guests and participants, it is my honor to welcome you all to the Self-Paced International Symposium 2024 organized by JAL, Joint Asian African Labs, on this significant occasion of World Water Day. Today's session features Dr. Vijay Nagpurkar, a distinguished expert in the field of water treatment, as our keynote speaker. Dr. Nagpurkar's topic of discussion is primary and secondary water treatment, a crucial aspect of ensuring clean and safe water for our communities. Dr. Vijay Sahib Nagpurkar is a highly accomplished academician and researcher with a wealth of experience and expertise. He obtained his PhD from Sri Satya Sai University of Technology and Medical Sciences, Sihor, Bhopal, Madhya Pradesh, in the year 2020. His journey in academia began with a strong foundation in organic chemistry, having completed his M.Sc. from Hislop College, RTM Nagpur University Nagpur, in 2007. With a career spanning over 13 years in teaching, Dr. Nagpurkar has made significant contributions to the academic and research realms. He has been recognized for his exceptional teaching skills, having accumulated 10 years of UGC-approved experience. Currently serving as an assistant professor, university-approved, and first-year coordinator at Surodaya College of Engineering and Technology since July 2010, Dr. Nagpurkar plays a pivotal role in shaping the education and research landscape in his institution. Apart from his teaching responsibilities, Dr. Nagpurkar has taken on various roles and responsibilities that showcase his dedication to academia and innovation. He has been nominated as an expert for the Innovation and Incubation Cell at SSJ College, Arjuni Mogaon, Gondia, for the academic years 2021 to 2022. This recognition underscores his ability to foster innovation and nurture budding talent in the academic community. Dr. Nagpurkar's commitment to continuous learning and professional development is evident from his participation in NPTEL certification courses on NBA accreditation and teaching learning in engineering. He has also served as a keynote speaker in workshops focusing on recent trends in examination for undergraduate students. Further highlighting his expertise and leadership in the field, in addition to his teaching and administrative roles, Dr. Nagpurkar is a prolific researcher with several paper publications in esteemed journals and conferences. His research interests span a wide range of topics, including chromatography, separation techniques, and the synthesis of various materials with applications in water treatment and environmental science. His publications and contributions have earned him recognition in the academic community, with a notable citation count and an impressive H-index. Dr. Nagpurkar's participation in seminars, conferences, workshops, and STTPs, short-term training programs, reflects his commitment to staying updated with the latest developments in his field and sharing his knowledge with peers and students alike. His active involvement in national and international conferences, as both a presenter and a participant, underscores his dedication to academic excellence and collaboration. Today, as Dr. Vijay Nagpurkar takes the stage to delve into the intricacies of primary and secondary water treatment, we are privileged to learn from his expertise and insights. His vast experience, coupled with his passion for research and education, makes him a beacon of knowledge in the field of water treatment and environmental science. Let us extend a warm welcome to Dr. Vijay Nagpurkar and embrace this opportunity to gain valuable insights into the critical aspects of water treatment that are essential for a sustainable and healthy future. Thank you.
Good morning, everybody. Myself, Dr. Vijay Nagpurkar, Assistant Professor at Suryodaya College of Engineering, Nagpur, Maharashtra, India. My topic for discussion is wastewater treatment, and in this topic I am precisely going to talk about primary and secondary water treatment. In this discussion of wastewater treatment, I am going to cover the content, preliminary treatment, secondary treatment, and whatever the sludge which is produced after the treatment of this water, that is sludge. We are going to discuss sludge handling also. The question arises, why we need to treat the water? Because water is polluted. There are some different treatments through which we can treat the water. but the pollution will decide, water pollution will decide which treatment can be used for the particular wastewater. So in this complete discussion we are going to I'm going to explain the complete process of wastewater treatment in brief. First of all, I'm going to discuss about preliminary treatment of water. The purpose of preliminary treatment is to protect plant equipment by removing those materials that could cause clogs, jams, or excessive wear to plant machineries. Removal of various materials at the beginning of the treatment process saves valuable space within the treatment plant. Preliminary treatment processes may include screening method, shredding method, grit removal, pre-aeration, chemical addition, flow measurement, and flow equalization. In the preliminary treatment, first of all, we'll do the screening method. Now in the screening method, floating impurities from the water can be removed. After screening, we send the water for further process. In the further process, we allow the water undisturbed to remove the small particles, solid particles from the water with the help of force of gravity. That process is known as sedimentation process. For the faster sedimentation, we add some of the chemicals that are known as coagulating agents like aluminum sulfate and sodium aluminate to make faster sedimentation process. In the complete process, flow measurement and the flow equalization is very much necessary. In primary sedimentation, wastewater enters in a settling tank or a basin. Solids that are heavier than water settles to the bottom, while solids that are lighter than water floats on the top. Settled solids are removed as sludge and floating solids are removed as a scum. The complete solid materials are distributed at the bottom and from the top. The solids which are lighter than water, they are float on the surface of water. So as a scum we can remove them, and rest of the solid materials are settled at the bottom due to force of gravity can be removed as a sludge. Wastewater leaves the sedimentation tank or an effluent weir and on to the next step in the treatment. Once sedimentation has done, the water is sent for the next step for the primary treatment. In this sedimentation process, most of the solid impurities and visible impurities are removed. Clarifier used may be rectangular or circular. In rectangular clarifier, wastewater flows from one end to other and settled sludge is moved to hopper at one end, either by flight set on parallel chains or by single bottom scraper on the travelling bridge. Floating material, mostly grease and oil, is collected by surface skimmer. In circular tanks, the wastewater usually enter at the middle and flow outward. Settled sludge is pushed to a hopper into a middle of the tank bottom and surface skimmer removes floating material. As we can see both the diagrams for the circular clarifiers and the rectangular clarifiers. In both the processes, we can remove the solid impurity as a floating solid impurities and settled solid impurities. Floating solid impurities is already we have discussed, that is known as scum, and the settled down solid impurities are known as sludge, that is removed from the bottom of the clarifiers. So there are some different type of clarifiers can be used, as you can see in the diagram. So different types of clarifier discussed by the wastewater flow direction and evacuating sludge system. So there are rectangular and circular clarifier as we can see in the diagram. Now this is a sedimentation process. As we can clearly see, the water has keep undisturbed in a tank so that whatever the solid impurities present inside the water are allowed to settle down with the force of gravity. Here all solid impurities are allowed to settle down and gradually supernatant water is removed with the help of pipes. This is known as primary sedimentation process. After primary treatment, we send or we treat the water in the secondary treatment process. The main purpose of secondary treatment is to provide BOD removal beyond that achievable by primary treatment. There are some impurities which cannot be removed with the help of primary treatment, so we have to treat the water with the secondary process. Here, the treatment is to provide biological oxygen removal beyond what is achieved by the primary treatment. There are three commonly used approaches. Two of these approaches are the trickling filters, which is also known as fixed biomass. Here we fixed the biomass inside the tank. And the next one is activated sludge process, which is also known as floating biomass. Sequentially follow normal primary treatment. The third process is known as pond process, is also known as oxidation ponds or lagoons, can be provide equivalent results without the primary treatment. So let us discuss about these secondary treatments. We are going to discuss fixed biomass process and activated sludge process in the secondary treatment. Here we are going to discuss the trickling filters. Trickling filters are tanks filled with solid media. The solid media are plastics, stones, over which the wastewater is trickled. A biofilm grows on media and metabolizes the organics in the wastewater using natural or forced draft. The organics which are present inside the water must be metabolized with the help of biofilm. So these filters allow all these organics which are present in wastewater to metabolize. In another words, we can say that this biofilm provides a platform to metabolize the organics in the wastewater. The film slots off, requiring a second clarifier to separate the sludge from the secondary effluent. Here, sludge is separated from the secondary clarifier. As you can see the diagram, more clear picture can be seen with the help of this trickling filter. Here, as we can see, the sludge treatment or secondary treatment can be shown very clearly with the help of trickling filters. As we can see in this diagram, the feed pipe is present at the center of the trickling filter. The wastewater is fed from the center and it goes above to the trickling filter, and then it's sent inside the tank of the trickling filter with the help of sprayer. Sprayer are used for the uniform distribution of wastewater on the solid film. Gradually, the wastewater react with this stone film or this wastewater film, and it metabolizes, and at the bottom we get the clarifier water or clear water, which can be sent to a different tank with the help of outlet. Now this is a real life picture for the trickling filters, where you can see it is in circular shape, and as you can see there are sprayers at the upper portion of the trickling filter, and there is the feed pipe which is present at the bottom, center bottom of the trickling filter. Now let us discuss about the activated sludge process. The basic component of an activated sludge sewage treatment system include an aeration tank and secondary clarifier. Primary effluent is mixed with settled solids, that is biomass, recycled from secondary clarifier and is then introduced into the aeration tank. Air is supplied continuously into the mixture. Wastewater is fed continuously into an aerated tank where the microorganism metabolizes and biologically flocculate the organics. Microorganisms, that is activated sludge, are settled from the aerated mixed liquor in the final clarifier and are returned to the aeration tank. A portion of concentrated solids from the bottom of the settling tank must be removed from the process, that is waste activated sludge. So as you can see clearly in the diagram, it's a activated sludge process where first of all what we do is we feed the wastewater along with activated sludge in the primary wastewater. Here all the microorganisms from the activated sludge metabolizes the organics in the wastewater and the clarifier water is sent to another tank. Here the metabolized sludge or solid material settles at the bottom and clear water will be comes as a supernatant liquid in the second tank, and that is considered as to be effluent, which is sent for the purification. And from the bottom of the second tank, we remove the sludge, which is again sent to the primary first tank, so that we can use that as an activated sludge. So in this way, the complete process of activated sludge is carried out. The another treatment, secondary treatment, is biogas reactor. A biogas reactor or anaerobic digester is an anaerobic treatment technology that produces a digested slurry, which is also known as a digestate, that can be used as a fertilizer, and biogas that can be used for energy. So there are two advantage of using this biogas reactor. We get the digested slurry, which can be used as digested or as a fertilizer, organic fertilizer, which can be used in the agriculture field. And biogas, it is used for as an energy, alternative source of energy, and biogas is considered to be a renewable source of energy. Biogas reactor is an airtight chamber that facilitates the anaerobic degradation of the black water, sludge and biodegradable waste. So this process can be applied for different kinds of wastewater like black water, which is generated from the gutters and different waste water outlet, then sludge and biodegradable waste. So this technology can be applied at the household level in small neighborhoods or for stabilization of sludge at larger wastewater treatment plants. It is the best used where regular feeding is possible. So where the bigger messes are used, where lots of wastage of food is generated, there this biogas reactor can be implemented, and we can generate the bioenergy with the help of waste food, and it can be used for cooking also. So there are pros and cons for the biogas reactor. Let us discuss about this pros and cons. Generation of renewable energy. We can generate the energy with the help of the bioreactor, and the energy is continuously we can generate the energy. That's why it is known as renewable energy. Small land area required. Most of the structure can be built underground. So very small area is required. No large area we required. So it is efficient and it is a reliable method, and structure can be built underground also. So it is very human friendly process. No electric energy is required. The complete process required no electric energy. The conservation of nutrients. This is the most important content, or the point we can have is we can conserve the nutrients long service life, low operating cost, requires expert design and skilled construction, incomplete pathogen removal, the digested might require further treatment. So there might be possibility that the complete digestion process could not happen. So incomplete pathogen removal can be sent for next treatment process or for further fermentation process. So these are some of the pros and cons for the biogas reactor. This is one of the best secondary treatment that we have and we can use to treat the water. So we can see this biogas reactor or to generate the biogas. So there is a inlet for the wastewater. The wastewater which is generated as from as a black water or the sludge and different types of the wastewater which are generated from different sources. So we collect all this wastewater at the in the tank. As you can see, the bioreactor tank is built up inside the soil. So underground construction is there. So whatever the sludge and wastewater is collected at the central tank, after the fermentation process or of the digestion process, the biogas, that is methane gas, is produced and it can be collected with the help of pipe which is known as biogas pipe. And after the complete fermentation process, it can be removed as a digestate from the another tank. And then whatever the slurry is generated, it can be dried and can be used for as a fertilizer or compost in the agriculture field. So this can be the best method as a secondary treatment for the wastewater. So this is a real life construction for the biogas reactor. As we can see, it can be built up underground. After the complete treatment, whatever the sludge is produced, we have to treat it or we have to handle properly that sludge. We cannot throw it in the environment as it is. So we are going to discuss about the sludge handling process in brief. The ultimate purpose is the conservation of wastewater sludge into a form that can be handled economically and disposed of without damaging the environment or creating nuisance conditions. Sludge treatment accounts for more than half of the total cost in the typical secondary treatment plant. Sludge treatment methods are generally divided into three major categories. First one is thickening, then stabilization including inactivation of pathogenic organisms, and then dewatering. Now the sludge, whatever is obtained from the wastewater, has different kind of percentage of water in that sludge. So the most importantly, we have to make that sludge thicken, means we have to remove the most of the water from that sludge. The second is it might happen that there may be some viruses, bacteria or pathogens present inside that sludge. So we have to stabilize that pathogens or that we have to stabilize that sludge, and we have to treat all the pathogens organisms present inside that sludge so that it cannot create a harm if it goes into the environment. And the last one, we have to remove the water from the sludge so that we can use it as a compost or as a fertilizer for the agricultural field. So a ratio of 1:2 or 1:3 between dewatered sludge, that is UDDT matter, and organic waste is mixed. Mixed material is spilled into a long heaps, that is windrows, and left to decomposes for approximately 3 months. Windrows are turned periodically to remove the oxygen and ensure that all parts of the pile are subjected to the same heat treatment. Now piles should be insulated with compost or soil to promote an even distribution of heat. Careful planning and design requires to avoid this failure. So this is what about the sludge treatment. So these are what some contents from the wastewater treatment. So in this topic we have discussed about the primary treatment. So we have discussed the what are the different primary treatments like screening method, sedimentation process, coagulation process. Then after that we have discussed about the secondary process, in which we have discussed about the uh, uh, activity sludge process, then the biogas reactor, biogas creation method, and finally we have discussed whatever the sludge is produced. We have discussed the sludge treatment from the wastewater, whatever the sludge is produced from the wastewater. So thank you for listening to my lecture, and have a nice day to all of you. Thank you.